Hello there, my name is Ibrahim, and in my pollution control project, we will be doing the thermal power plant as our main topic. So as you can see there, that the course learning outcome number 3 is about to describe the regulatory framework for pollution prevention. So that is one of the objectives that I'm trying to achieve by doing this project. Okay, so moving on. Okay, so these are some of the topics that will be discussed in today's presentation. One of it includes introductions, potential pollutants in the industry, rules and regulation, competency relevant for pollutant control measure, processes involved for pollutant control measure, as well as the conclusion. So in the introduction part, we'll be discuss about the task that has been given, and as well as some of the objectives that we need to achieve. Okay, so in the introduction, the students have been tasked to describe the regulatory framework for pollution prevention. So in this case, I have been tasked to actually describe the regulatory framework for pollution prevention, specifically in a thermal power plant. So this project will be focusing more on the regulatory framework that are involved with a thermal power plant. So such as what are the competencies as or certificates that are needed for a particular personnel to or even a company or entities to actually need to comply with, specifically those that are linked with the thermal power plant. So moving on. Okay, these are just the CLO that has been mentioned previously. Okay, these are some of the potential pollutants in the industries. So, okay, so you can see here that the first one here refers to sulfur dioxide. So sulfur dioxide is primarily produced when fossil fuels containing sulfur, such as coal and oil, are burned. It is a major contributor to acid rain and can have a detrimental effects on human health as well as the environment. So this SO2 is actually quite dangerous. Moving on, we also apart from that we also have nitrogen oxides. So nitrogen oxide is formed during the combustion of fossil fuels at high temperatures. Usually, it includes nitrogen dioxide and nitric oxide. So, nitrogen oxide emissions contribute to smog formation, respiratory problems, and the formation of ground level ozone, which can be harmful and detrimental to our health. So, one of the examples has happened in the UK previously. So, yeah. Apart from that, we also have, as you can see here, particulate matter. So, particulate matter consists of tiny airborne particles, and it can exist in either solid or liquid form. It includes both fine particles, which is around 2.5, and coarse particle, which is around 10 PM 2.5 or PM10. So it can usually be released during the combustion process or from sources like coal handling, ash handling, and stack emissions. So, particulate matter can also have an adverse effects on air quality and human health, especially when it is inhaled into our body. Okay. Okay. Next, we also have this carbon dioxide. Carbon dioxide is a greenhouse gas which is responsible for climate change. So, it is released when fossil fuels are burned, which makes thermal power plants a significant source of CO2 emissions. So most of this carbon dioxide came from a thermal power plant. However, efforts are underway to reduce the CO2 emissions through carbon capture and storage, which is known as the CCS technology. Okay, carbon capture and storage, or transitioning to either low carbon or renewable energy sources like solar power plant or wind and turbine energy or water hydroelectric dam. Yeah, so those are some of the examples of renewable energy. Next, we also have mercury. So mercury is a toxic metal that can be released from burning coal and oil. It possesses a significant environment and health risk because it can accumulate in the food chain. So particularly in fish and seafood especially. So when the humans consume this fish and seafood, it also affects us indirectly. Okay, so next we also have ash and particulate matter. Okay, thermal power plants produce ash as a residue from the combustion process. So as you can see, usually a thermal power plant would usually produce ash and particulate matter because it involves combustion process. So these ashes, which is fine and light, is carried up with flue gases, while bottom ash, which is usually a coarser, settles at the bottom of the combustion chamber. So both type of ash can contain heavy metals and other toxic substances, which require proper management and disposal to prevent any environmental contamination. Okay, next we also have VOC, which stands for volatile organic compounds. Okay, volatile organic compounds can be emitted during fuel combustion from car or motorcycles, or it can also produce from other sources in the power plant, such as solvent use or leaking. So that one can also, those scenarios can also contribute to the release of volatile organic compounds. VOC contributes to the formation of ground level ozone and may also have an adverse health effects. So it can harm the human well-being. Okay, that's one, which is HAPS. It stands for other hazardous air pollutants. So thermal power plants may emit various other hazardous air pollutants, which includes but not limited to lead, arsenic, nickel, or even chromium, and some even like polycyclic aromatic hydrocarbons. So these pollutants, all of this can have a severe health and environmental impacts, but it depends on their toxicity and exposure level. So it depends on the level of toxicity and how long a particular person is being exposed to that particular toxic. So yeah, so these are the potential pollutants in the industry that I have just discussed about. So let's take a look at the next section. Okay, so the next section is about the rules and regulation for pollution prevention. Okay, as we can see here that we have the emission limit. So thermal power plants are subject to various rules and regulation to prevent pollution and ensure environmental protection. So while the specific regulation can vary between countries and regions, there are some common rules and practices that have been implemented in thermal power plant to prevent pollution. So one of it is emission limits. Emission limit, okay, power plants are typically usually required to comply with emission limit for pollutant like sulfur dioxide, nitrogen oxide, particulate matter, as well as mercury. So these emission limits are set by the Environmental Regulatory Agency, and it may vary depending on the plant's location as well as the type of fuel that is used by the plant. Next, we also have the air pollution control technologies. Power plant use various pollution, but in this case, the thermal power plant, it utilizes multiple types of pollution control technologies to reduce emission. So that one is the compulsory thing that they need to have. Otherwise, they will be the thermal power plant needs to be closed. So they have to comply with these pollution control policies. So this technology may include electrostatic precipitator (ESP) in short, electrostatic precipitators, which is able to capture particulate matter, flue gas desulfurization systems, uh, to remove sulfur dioxide, as well as selective catalytic reduction. Yeah, the SCR, selective catalytic reduction or selective non-catalytic reduction system, which can reduce the nitrogen oxide emission, as well as the activated carbon injection or even mercury control system to control the mercury emissions. Okay, moving on to the next one is we have here is the ash and solid waste management. So thermal power plants generate ash and other solid waste which is needed to be managed properly to prevent any environmental contamination. That one is, yeah, it's obvious. And then regulation may require power plants to implement to apply ash handling system. For example, the most common one is the electrostatic precipitators, or also known as baghouses, which is used to capture ash and prevent its release into the environment. So the disposal and management of ash and other solid waste are usually regulated, and power plants may be required to follow a set of specific guidelines for storage, transportation, as well as the disposal of this particular ash. Okay, next we also have water pollution prevention. As you can see, there's a whale here. So this is basically talks about the water pollution prevention. So thermal power plants will usually consume significant amount of water for cooling and other processes. So a huge amount of water is needed for the cooling processes, right? So to prevent water pollutions, power plants are often required to use or implement systems for treating and recycling wastewater. So cooling water discharge, for example, once a particular thermal power plant has used cool water, then there will be some discharge that is coming out from that particular thermal power plant. So this water discharge must meet the specific quality standards to protect the aquatic ecosystem. And regulation usually may limit the temperature increase of discharged water to prevent thermal pollution. Because if you imagine that, for example, the temperature of the water that's coming out of the thermal power plant is just too hot, right? Then usually it will disrupt, or it will disrupt the aquatic living, which can affect the health of other micro organisms in that particular seawater. Okay, next we also have the environmental impact assessment. So before constructing a thermal power plant, an environmental impact assessment is often required, which is usually the case. So this assessment evaluates the potential environmental effects of the plant, which may include air and water pollution that we mentioned just now, habitat disruption, as well as other impacts. So environmental impact assessment is required because it helps to identify measures to mitigate the impacts that I mentioned earlier, as well as to ensure the necessary safeguards are in place. So environmental impact assessment is very, very important. Excuse me. Right. So we are moving on to the next point, which is the monitoring and reporting. Power plants are typically required to monitor and report their emission. So all of the emission that's coming out from the thermal power plant needs to be reported, as well as the effluent and other environmental parameters on a regular basis. So this monitoring ensures compliance with regulatory limits, and it also provides data for assessing the plant's environmental performance. So regulatory agency may also conduct inspection from time to time and audit, and to verify compliance with regulations. Okay, for the renewable energy integration, like I mentioned in the previous slide, some regions encourage or mandate thermal power plants to integrate renewable energy sources like solar or wind into their operation and processes. So this would in turn help to reduce greenhouse gas emission and reliance on fossil fuels, because renewable energy does not pollute the environment. Yeah, so that's why the some of the policies are required, have been implemented to make sure that they include some renewable energy in their processes and operation. So it is important to note that there are some specific rules and regulation that are applicable to a thermal power plant and may vary based on the jurisdiction and the specific plant's characteristic. So there are certain characteristic that needs to be identified, because so different plants characteristic have different rules and regulations. So that is one of the things that we need to keep in mind. So yeah, moving on to the next slide. Okay, so this is the competency relevant with pollutant control measure. So first one, we have the environmental engineering, right? Okay, so a knowledge of environmental engineering principles and practices is very important or crucial to understand, to help us understand the sources of pollution in the thermal power plant, and it also helps us to identify some of the control measures. Okay, so competency in areas such as air pollution control, water pollution prevention, and solid waste management is also essential in environmental engineering. Okay, so next we also have the regulatory compliance. Okay, understanding and staying up to date with environmental regulation and standards that are applicable to power plant is essential. So it is compulsory. Competence in interpreting and implementing regulatory requirements helps to ensure that the plant operates within legal boundaries and meets the compliance obligations. Hence, regulatory compliance is very important. Next, we also have the pollution monitoring and analysis. So, competency in pollution monitoring techniques and equipment is necessary to measure emission, effluent, and other pollutant accurately. So, this is I would say that this is one of the most important aspect when it comes to competency relevant with pollutant control measure, because we by having a high level of pollution monitoring analysis skills, we'll be able to actually know exactly the amount of pollutants that has been released into the environment, so that we know exactly its impact to the environment. So if it's good, then we can reduce the emission. Otherwise, we will need to actually treat the emission or effluent with some kind of process or treatment, so that we'll be able to help to reduce or mitigate the negative impacts to the environment. Okay, next we also have the pollution control technologies, right? Okay, so familiarity with various types of pollution control technologies that are used in thermal power plants is also important. So these include knowledge of systems like electrostatic precipitators that I mentioned just now, flue gas desulfurization units, selective catalytic reduction system, as well as control measure. So yeah, understanding the design, operation, maintenance, as well as troubleshooting is also important for effective pollutant control. So pollutant control technologies plays a significant role, okay, in the aspect of competency in this particular framework. Okay, next we also have the data analysis and reporting. So competency in data analysis and reporting is crucial to let us monitor and to assess the effectiveness of pollutant control measures. So this may include proficiency in using some data analysis software, or apart from that, it also includes proficiency in interpreting monitoring data, preparing accurate reports, as well as having the ability to communicate findings or the things that we have discovered to relevant stakeholders. So this is one of the most important competence factors or point that needs to be addressed. Okay. Next, we also have the processes involved for pollutant control measures. Okay, so implementing pollutant control measures in a thermal power plant, right, would usually involve multiple processes that are aimed to reduce the emission and to mitigate the environmental impact. So here are as you can see here, these all are the key processes that are involved. This 1, 2, 3, 4, 5, and 6. Okay, these are the key points. So let's start with the emission inventory and characterization. So the first step is to conduct an emission inventory to identify as well as to quantify the pollutants that are emitted from various sources within the power plant. Okay, this may involve measuring emissions of gases like sulfur dioxide, like I mentioned just now, and nitrogen oxide, as well as other particulate matter or other pollutant like mercury. So characterizing all these emissions helps to determine the scope and severity of the pollution. So it does help. Next, so emission inventory and characterization is basically just having the ability to characterize the emission, so that we know exactly the type of emission as well, along with its impact to the environment. Next, we also have the regulatory compliance assessment. So the plant's emission are compared against applicable environmental regulation and standards to assess compliance. So this may include understanding the specific emission limits, like how much the emission limits needs to be max at or minimum. So the limits needs to be identified. Apart from that, the reporting requirement as well as the monitoring guidelines set by the regulatory authorities should also be notified to the employees so that they'll be able to know and understand. The compliance assessment also helps to identify areas where pollutant control measures are necessary. So there are some aspects where pollutant control are necessary, and one of the ways that the employees will be able to know that is by using the regulatory compliance assessment. Next, we also have the pollution control technology selection. So based on the identified pollutant and regulatory requirements, appropriate pollution control technologies are selected. So this may involve evaluating the effectiveness, efficiency, and feasibility of various control measures like electrostatic precipitators, flue gas desulfurization systems, selective catalytic reduction, what else? Fabric filters, as well as other advanced treatment methods. Okay. Apart from that, the selection process consider factors like pollutant removal efficiency, cost, energy consumption, and compatibility with the plant existing infrastructure. It has to be compatible, otherwise, no use. Okay, uh, otherwise it will be pointless. So moving on to the next point is about the engineering and design. So once the control technologies have been chosen, the engineering and design phase begins. So this include detailed design of the control system, equipment sizing. So the control system has to be designed in such a way that it fits the needs of the particular company, as well as fits the needs that has been set by the regulatory, so that they'll be able to comply with the rules and policies that would be friendly to the environment. Um, yeah. So apart from that, other details of the design may also include, for example, equipment sizing, layout planning, uh, as well as integration with the power plant's processes. Yeah, so it has to integrate with the process of the power plant so that it does not disrupt. So engineering considerations such as like pressure drop, airflow, what else? Temperature requirements, temperature levels, and the as well as the material compatibility should also be taken into account during this phase, because these are some of the common factors that needs to be addressed. It is a common and critical factors that should be addressed. Yeah. So next, we also have the installation and construction. So the control system and associated equipment are installed and integrated into the power plant infrastructure. This involves procurement. Procurement is basically we try to get all of the materials that are needed for this particular construction of the design. Construction of the project. So of course, procurement, we need to have a good supplier that would be able to actually help us to supply us with the high quality materials. Apart from that, it also involves construction and installation of pollution control equipment like a scrubber, baghouse, treatment unit, or catalyst. Yeah. So proper installation techniques, adherence to safety standards, as well as quality control. Yeah, quality control is very important. So quality control measures are essential to ensure an effective implementation. So quality control is extremely important, especially when it comes to installation and construction. Next, we also have the commissioning and performance testing. So this may involve verifying the proper functioning and performance of the pollution control equipment under normal operating condition. Testing may include assessing pollutant removal efficiency, pressure drop, system stability, and other performance parameters. So adjustment and fine tuning may be made to optimize the control system. So there might be some settings that is required to optimize the control system so that we'll be able to have the optimal performance. Okay, so I think that would be 58. Moving on, is there any? Oh, okay, no. So yeah, that's it. So these are just some of the reference that I use for this particular project. As you can see here, one is from Chandra from 2019, Karak, Singh, as well as Uyang. So I get all this from a journal. So yeah, these are just the references that I use. Actually, there are more than 4 references, but I have like 10. I think I have 10 references, but I just, due to the space limit, I just put in 4 here because I don't want to put too much. So yeah, think that's it. Yeah, thank you for listening. Thank you so much and have a great day.